Mernin.
Good morning. Filming this, I think, doubles the amount of time that is invested into any one episode.
Yeah. So for our 6 viewers and our 7 listeners, we're going through...
Is that how many views we got?
HE double hockey sticks.
Is that how many views we got? 6?
Like times 100.
Oh, okay. I haven't looked.
It's a considerable investment.
Looking. How many times a day are you looking?
I looked once yesterday.
Okay. That's it?
Okay, 10 times. No, I'm just kidding. Just once.
All right, cool. Well, we got that first one out of the way, and this is going to continue to evolve, and I think that we'll change it up a little bit each week until we perfect it, right?
You brought notes.
I do have some notes, yeah.
That is cute. This is the first time he's ever brought notes.
Is that true?
I don't know. Maybe in like the negative episodes, but you bring a lot to this just right there. Yeah. Right in the old bear trap.
These notes just say, smile, be kind.
That is important. Tyler is verbally abusive when we're not on the air.
Pretend you're happy.
He's not joking. So right quick, I want to get a couple things out of the way.
Okay.
We, like I said, I think an episode or 2 ago, we tend to make promises that we don't necessarily follow up on.
Yeah, you said that. I don't know if I actually agree with it, but you did say it, so let's assume it's true.
Well, then tell me something that we need to follow up on today.
I couldn't.
Exactly. So we had Jeb, remember? I messaged him live.
You interrupted me.
Yes.
And then you're like, this is super important. And then
we never got to it.
We came out of the room and I was thinking, I don't think we ever actually came to a conclusion there.
Yeah. How do you think our listeners feel?
They're probably got the pitchforks ready. All right, so let's hear it.
All right, so this was in terms of Origin 1 part saturation. So if you finish a print and you just let it sit there in the resin or let the raw resin just kind of hang off it, what are the consequences?
Okay.
His response was, quote, "The parts can absorb the liquid resin, causing them to swell up and lose geometrical accuracies. Long term, if too much resin's absorbed and not given adequate time to be washed out or cured, the parts can start to sweat material."
So that's sweaty parts.
Sweaty parts.
You don't want sweaty parts.
Not now, not ever.
Not ever.
So that's the one thing I think for sure we had to follow up on. Another thing, we told folks that we were going to give them an AMUG update.
Yeah, that is true. We did do that. So are we going to make true on that? Is it happening?
Yes, it's going to happen. We are bringing in an expert today.
Oh.
And we have him on the phone.
This is our first official guest.
Yes.
In episode 45, our first official planned guest.
Yeah.
Let's hope it goes well.
Yeah, so I have him on the line and I'm going to act like I'm hitting the soundboard right now. Okay. Richard, are you with us?
I am with you.
He's here.
Hello, friends.
Hello.
Hello, Richard. Tell us real quick who you are. Introduce yourself.
Yeah, thanks.
Oh, wow. Certainly. My name's Richard Cromwell, and I am an additive manufacturing applications engineer from GoEngineer out in Auburn Hills, Michigan.
All right. So you're our brother from another part of the union. that was not a saying that people say at all. And Tate is leaving.
It's gone. It's gone. We got this.
Okay. Richard can't see us, by the way.
Richard?
Yes.
Tate,
I think I can do this. I can do this by memory.
As soon as you started talking, Tate got up and left.
This is typical of what I do. I do it to Tyler too. Before we had video, I would do it all the time, and Tyler would just carry the show while I was off doing something else.
That would totally happen. I would have to go into this monologue totally unplanned because Tate left the room.
It worked really well, but we want to hear about what was cool about AMUG. You said that you attended a couple
sessions.
A couple sessions, and some stuck out to you. I wanted you to talk most about the GM one and what stuck out.
Oh, for sure. Yeah. I attended a lot of sessions. I tried to attend as many as I could because and there were quite a few situations where I couldn't go to two that I really wanted to attend both of them. But my favorite technical session was called Additive Manufacturing Application Selection at General Motors.
Okay.
And the coolest, I liked that one a lot because it applied directly to what I do every day at GoEngineer as an application engineer. And it was primarily a discussion of General Motors' internal workflow for validating additive applications. And the gentleman went into quite a bit of detail. Some of the things that I thought were really, really cool were like that they create their own material data sheets rather than relying on OEM data.
Yep.
And
can you tell us about the differences? Were there any like stark differences where you're like, okay, I get it. I get why they're doing that?
No, because they weren't sharing those specific, they just talked about how that's what they do, but they didn't give any specific examples. But based on how they were, how thorough they were in other elements of the process that they discussed, I can imagine that, you know, it's going to be really comprehensive and useful information.
Yeah, I would say that's not uncommon for the large OEMs to trust no one when it comes to knowing and understanding the behavior of the materials.
Well, and it goes in line with kind of our theme.
Yeah.
Our theme is trust no one too.
Yeah, exactly.
Yeah, so that was just like one thing that they did, and I thought that was neat. The other thing was like their actual like processes and workflow that they go through. So like the questions that they ask, the engineers that come to them with the ideas of, you know, things that they want to have 3D printed. So like they would interestingly use a solution versus requirement focused concept where they would say like, well, why should we not use additive for this? That was like one of the first questions that they would always ask. Is there a better way of producing this than additive? And then if they could say no, then, you know, then it would default to going back to the additive. And then they had like lists of common questions that their engineers would be asking when considering, you know, what process or what material to use. And they have like these forms that the engineers have to submit that have like detailed drawings and, you know, surface finish, call outs and all these things that were, you know, for critical surfaces, what's really important so that they could come up with the best orientation, the best material, and the best process.
So,
and yeah, go ahead.
No, go ahead.
And like they had some examples of internally developed like application guides and best practice guides, and I thought that was really cool. And it's something that moving forward, I'm spending more of my time working on application guides. And then they had you know, and that was just like the first part of it. The rest of it went on of talking about GM's, you know, how they analyze the economics of AM and their supply chain, how they interact with them through AM. And then they had a bunch of case studies at the end. It was overall, it was a really good presentation. And you know, the slide deck is excellent. And he gave some other additional resources, you know, for application engineers that I think
we may want to share that.
I don't know if we can.
Not yet, but we may want to share that, Richard. So if we can get those or someone reaches out to us, we can at least forward that to them. Oh, can we not? Because of...
I don't know. Look at you being so cavalier with the law.
Wow. Really?
Yeah.
This is a great segue right now into our next topic, but I'm not going to go there. Richard, tell us like what machines stood out to you?
Oh yeah. On the expo floor, they had tons of machines. And I got to see some really neat ones. I mean, I'm kind of biased. I wanted to see the Neo 450 that they had there because we're getting one at our lab here in Detroit. And it was neat to be able to see one in person. And
was it love at first sight?
It was.
Did you hug it?
I climbed inside of it.
And you just took a nap inside.
Yeah. I just curled up onto the build platform.
Yeah.
But the
Oh
probably probably the coolest printer that I saw outside of that was the from Boston Microfabrication. Uh, I like PolyJet a lot, and it's a neat technology because it is so precise and accurate, and you can get really fine resolution both in Z and XY, and it's just a great technology. But I've run into problems where, trying to print microfluidic devices in the past and things like that are really, really small. It just didn't even have the resolution for some of the medical devices that people were asking us to print. And so this technology basically uses like a DLP light engine, but then it pushes the light through rather it's like an inverted microscope. So it makes the DLP pixels so tiny. And then there's special resins that they have that they can cure using the system to make incredibly tiny, like the resolution is 1 micron, and X and Y, and their layer heights, I think, are 2 microns.
How big is the build platform on that?
Oh, it's tiny,
an inch by an inch?
It was probably no. Really? They had a little bit bigger than that, but
okay.
It was a very impressive to see the parts that they were able to turn out.
And is that a commercially available machine?
They made it seem like it, and if you go on their website, they have quite a few different models. So I'm going to say that they're cranking out some machines.
All right.
Cool. Anything else stand out?
Oh yeah. Well, the Massive machine, which is like an FDM style printer that was the size of a garden shed. That's pretty impressive anytime you see it.
Our old friend Ben Arnold is at Massive now, and he got his Dino Award at AMUG.
Oh wow, year. That's awesome.
Which is it's a big honor for people in the additive industry. I think there are about 175 AMUG Dinos now out in the wild, and they added 3 this year, and Ben was one of them. So that was well deserved. He's been in the industry for a long time, and one of the trusted people in the industry, from my perspective, for sure.
Yeah, I went to a panel discussion that he was really good.
Cool.
And it was specifically on like validating machines using benchmarks. It was a really good discussion.
Yeah, nice.
And the other thing that I saw that was really neat was the DMG Mori system, which was it's like a hybrid 5-axis CNC that also has a direct energy deposition head in there. And so, just from a CAM and 3D printing perspective, from like a software perspective, I was pretty impressed with that.
Yeah, we've talked about hybrid machines in a past episode, and a large part of that conversation was around the programming of those machines. Did you happen to talk to them about how they program those?
I did, because that seemed to be like a bottleneck to me in that process. It seems so complicated.
What did they say?
They told me to go talk to the software vendor, so I did. And I think the company was Hexagon.
Okay.
Was one that I talked to, and they are using like a Spree as the backbone for their system, and it does allow you to do like additive and subtractive. Their workflow looked relatively reasonable, and and I don't really know too much about the Spree. It seemed like they had a good software solution, and but to me, the cost of the machines was kind of absurd. But it's interesting too, because it seemed like such a hot topic, because there were a lot of different metal was a very hot topic at this AMUG. Polymers almost seemed like a foregone conclusion, and so it was a real eye-opener to see what people are thinking of and what's available and the trends.
You mentioned a little bit about the balance of like metal to polymer. It seemed like polymer seemed like a foregone conclusion. Can you talk a little bit about your perception of the show and that balance?
Yeah, I was really surprised at the ratio of metal additive people there and polymer people. I mean, it was definitely 50-50, but a lot of the people that were there talking about polymer, using polymer, they were still super interested in metal. And then also, like, it was interesting to see the range of materials. Like, that was a good way to measure how different technologies, like how pervasive they are in a way. And you could see, like, powder metal is just huge. There were so many different powdered metal vendors and some big names like Sandvik, and then they had a lot of photopolymer resin, but there weren't a lot of, like, like filament people there. There were a couple, but it was a lot of powder. Even the polymers was quite a bit of powder, and there was a lot of powder. But there were a lot of, like, kind of like lesser expensive but still quasi-industrial manufacturers coming out of, like, Korea, and so that was something that I thought was interesting.
So,
because yeah.
Well, go ahead.
Well, but the machines weren't bad. I mean, they're relatively
we knew that.
Good, but overall, the takeaway would be that metal is going to be a huge part of the future.
And it goes along with the theme of what we hear every day. When we have customers come in, they always ask, hey, even if they come for a polymer machine, it might be when they're leaving the building, like, oh, so where's metal at right now?
Yeah, I just had that happen, and
it's been that way for 10 years.
Yeah,
it's been that way for 10 years. The industry is definitely changing, and every year at AMUG is one time where people who are in the industry can come together and kind of catch up and fill each other in on all the little gaps. And I was happy to see it continue again. I've always wondered, if you think of knowledge as like a national security, has some national security implications, and manufacturing ability has some national security implications. I always wondered, should I stay away from AMUG? Because that's a lot of people that all have very, very specialized knowledge all in one place.
Yeah, no, that's true.
It's a little conspiratorial, but I've just always wondered. Your
name's on a list somewhere.
I know, right?
Like, you're a target.
Yeah. All right. No. Well, thank you for the update, Richard. We appreciate that.
Yeah, you're welcome.
And I'm glad that you were able to go. And both you and Tate are going to be at Rapid soon, right?
That's right.
Yeah, that's going to be super exciting.
On to the next show.
Cool. Well, thanks for joining, Richard. We'll catch up later.
All right, fantastic. Thanks, guys. Talk to you later.
See ya. All right. Are you happy that we
had a guest
made due on our promise there?
Yeah, we did. So it's funny, while he was talking about GM, I couldn't help but think, like, they're doing all their own work on the back end, and it really does feed into the theme of what we've talked about for forever. It's like, yeah, we'll take your word for it, and everyone's giving them free systems.
Yeah,
you have to imagine GM has everything. Well, they're a beta customer for everybody.
Yeah, but that doesn't necessarily mean the system is free.
Yeah, it comes with some strings attached.
Let's just say OEMs are incentivized to be able to say GM is using our machines.
Right.
They're incentivized by that.
Well, and they're doing their own validations that they can pass along then to the OEMs. So
if they're willing, that usually comes to a negotiation. Because a lot of times, I mean, they're investing in that information. So it has value. It's a competitive differentiator. And if you find that maybe the rest of the market is being misled and you're not, that's valuable information. So generally, I wouldn't be surprised if people wanted to keep that information close to their chest.
No surprise.
Yeah.
People just hanging on to that IP. We've talked about that before.
Yeah.
So I want to get into something.
Okay.
This is on topic of keeping the law.
Okay.
All right. The other day you ran into a little issue with
I broke no laws. Let's just start there. I broke no laws. I know where you're going. I broke no laws. I have never.
So let's set the background for this a little bit. You, as one of your, you're so mad at me right now. Can we get a tight shot of his face here? So you talked about YouTube of the day not too long ago was the Mountain Fortress Labs.
Yeah, Mountain Fortress Labs.
Is that the right one?
Yeah.
I went back, I watched his full video with Heavy D and all that stuff.
Yeah.
And I'm like, this is Tyler.
Oh, God.
This is Tyler. And because you had just purchased a new toy, can you tell us about it?
I hadn't just purchased one at that point.
You were about to. You've been dreaming and scheming.
You probably saw a trend in the YouTube videos I was talking about. They became more and more about heavy machinery because in the background, I was thinking, man, I got to get a bigger shovel because I'm just digging dirt in my tiny yard, just moving dirt from one side of the yard to the other for like 3 years, destroying my body. I was like, I got to get a bigger shovel. So I found a way to get a bigger shovel.
And what did that bigger shovel end up being?
A Cat 303.5.
Okay.
Mini excavator.
So on your first project, you did break the law.
No, I didn't.
Because you dug without.
I back scraped. I backbladed.
And
I dug a little bit.
What did you happen to hit?
I hit my internet cable. I took my internet out.
Oh my gosh.
The fiber cable. The fiber cable was buried like 6 inches below the ground.
I think that's pretty common. I don't think they put those very deep.
Yeah, it should be at least 7 inches.
So I'm going to do a PSA and say call 811 if you're going to be a Tyler and you happen to have a really big shovel. I mean, I think you're supposed to call them even if you're like just digging, putting a shrub in.
Probably. You probably have to call 811 if you look at a shovel.
Well,
no, out where I live, there is no law. You have one sheriff.
It's the Wild West.
You have one sheriff. And if you're buddies with him, you can do whatever you want.
So you've worked that magic already.
No, I never talked to him. I don't talk to cops.
He's gonna know who you are here pretty soon. Well, that didn't have much to do with additive, but that may be a recurring theme during this podcast. And if nothing else,
what'd you break this week?
Yeah. Pretty much. So speaking of things you did this week, you brought something in for us.
Yeah, I don't want to focus too much on it, but I did bring in some show and tell because I really like these parts. It's not a very compelling part. The best way to describe it is like a large fidget spinner.
Is that what it actually is?
It's a project for a friend, and I think that is exactly what it is. But there's a lot of threads on this part.
Are you saying you don't know?
I think it's a large fidget spinner. I designed it and to his description, and I'm pretty sure it's like a large fidget spinner. But so the print quality is amazing. I think that's why I brought it in. It's the ABS CF10 off our 370. So you had some parts off the 370 last week.
Yep.
Looks really similar. You have, in this case, you still have some support material on there for the threaded portions. And should we crack it?
Yeah.
Should we crack it?
Let's crack it.
Are you ready? All right.
Oh, that's nice. Are you gonna be able to
strong enough.
I can see. I can see you shaking. Oh, do we get a close up of that, please? Oh my goodness.
So this CF10, I mean, it is
pretty stiff.
Pretty stiff. That carbon fiber fill, it's a chopped carbon fiber fill. The 10 is a 10% by weight, and it adds rigidity. It adds rigidity and stiffness to the underlying material, which in this case is ABS. I think this is quickly becoming my favorite material to print on the FDM side.
Well, it's matte and it's black.
It looks amazing.
So it looks great.
Yeah.
And the threads are what I'm most impressed with.
The threads look fantastic.
This probably isn't going to focus very well.
It actually probably will.
You think it will?
Yeah.
Is this the autofocus camera?
Yeah, that's a good camera. That's like the top.
That's the best one we got.
Yeah.
So you mixed some parts here too. There's some origin parts on here.
Clear origin parts. Yeah, I don't actually know the material off the top of my head, but it's a clear origin part.
I think it's a BASF material.
Yeah.
But I'm not sure the number.
So ABS Cf10.
Thanks for the show and tell.
Yeah, definitely.
I wonder if people like that. the sounds, the crackle sounds. Or I wonder if it at least gives some curiosity to where they're like, yeah, let's go check it out
Tell
on
us
YouTube.
in the comments.
Yeah, do tell us in the comments.
We do have a dynamic though. If people are listening to us as a pod versus watching on YouTube, there's going to be about a 1 week delay. So if you're listening to the pod on your like Spotify app or podcast app, and then you come to YouTube looking for the video, it's going to be about a 1 week turnaround time. So just a heads up there. Don't go on a wild goose chase.
We've got our content person right here. Is there a chance it'll ever speed up turnaround time?
No.
Count on 1 week. Count on 1 week.
Perfect. Thanks for setting that expectation.
Yep.
Tyler's always thinking about the people, even though he...
A man of the people is what it will say on my gravestone.
No, it's not going to say that. That's me. That's what I bring to this show.
It is true.
My buddy called me the other day. He listened to the first episode.
Okay.
And he's like, Tyler's the really smart guy. And I'm like,
it's kind of him.
I'm
not true, but kind.
And you're the everyman, and you help in that way. So if I can be that, that's what's going to be on my gravestone.
That's who I wish I was.
Oh, please. Wow. Look at him try and cater to the regular folks.
Can you tell I'm uncomfortable?
It's like,
it's not a lie.
So, speaking of my buddy, when he called, he gave me a couple good ideas for the show.
He called you to give you some feedback.
Yeah.
Yeah. Okay.
And it was good.
Okay.
It was good, but I think that's because the other pods out there that are surrounding 3D printing,
are better.
Additive manufacturing, aren't as good.
They're different. We're all different. We're all different.
Oh, now, wow. Very diplomatic you've turned into ever since we've been on film. Just go back to the first episodes, people. If you want to know the real Tyler, you got to go back before episode 44. Because, this is 45, and this is only our second episode on film.
I told you, things are going to be different.
Tyler's a different guy now. Now, you have notes. Is there something you wanna talk about? You got a news story?
Anything? I did have a news story. Yeah. Do you want to listen to it this week?
Yeah, I won't tune out.
Well, you had a topic too, and we have like 5 minutes. So
we'll save this for next episode.
Are you sure?
Yeah.
Okay. Well, there was a news story that made a lot of major news outlets this week about a new material that NASA developed.
Rockets. Are we now that you have your big shovel, are we back onto rocket obsession?
Okay, so this type of material is generally used more for nuclear applications, but it's a great fit for rocket applications too. And also things like hypersonic applications. So like scramjets. Do you know what a scramjet is? Oh my gosh. Let me blow your mind.
Okay.
Imagine a jet propulsion technology with 0 moving parts that only operates at Mach 5 and above. 0 moving parts. And we've tested.
This is like Colin Firth's little bicycle, his jet bicycle. It has no moving parts.
No.
It's got like a spark plug. Obviously, he's not traveling at Mach 5 on his bicycle.
No moving parts? How does he generate thrust?
Heat.
I don't think so. I don't think so.
Tell me how this scramjet works, would you?
The scramjet works by you have a volume of air coming in at high speed, and you direct it through geometry and compress it and you introduce a fuel, and it ignites, in the geometry of the scramjet does all the work. So it creates thrust by accelerating the air out the backside after it's been ignited.
I don't know about the isolator and combustor, but I do think that the Colin Firth, that's his name.
Yeah.
His jet works the same way, or the turbine, or whatever. Is it FIRS?
I think it's FIRS. Anyway, scramjet technology only operates at Mach 5 and above. And at those speeds, you can imagine you generate a lot of heat from the air friction, et cetera, et cetera. And this material could help in the pursuit of hypersonic aircraft, which is an area that every advanced country in the world is working on hypersonic technology And it's accelerated and enabled largely by additive manufacturing.
How so?
Well, we're talking about really exotic materials, first and foremost. And when you use something like powder bed fusion, you can create materials, super exotic materials that are constructed materials. So in this case, NASA, this is my note, GRX 810. That's the name of this alloy. It's an oxide dispersion strengthened material, ODS material. So oxide dispersion strengthened. So we're familiar with oxides, right? It's usually, we think about it as corrosion on the outside of a part. You have oxygen molecules binding with the metal molecules and creating an area of oxidation. And it's also the reason why when you're welding, you have inerting gas, something like argon or some other noble gas that is not going to be, oxygen's not going to bind to a noble gas, right? And it's shielding the area so you don't have oxides inside your metal. And we do the same thing in laser sintering, right? Generally you don't want oxides in your parts. But what these materials do is they strategically place oxides, either like yttrium oxides or alumina oxides, in a way that they strengthen the grain of the material. So when your material breaks, you have grains that are slipping. And think of these oxides as like almost glue or some obstruction that resists the grain movement, and it strengthens the materials. So NASA used some computational methods to develop and model the alloy, and then they used to create these materials. The base powders is a huge process. I started researching it, and I found some papers going back
using your outdated login information.
Totally legal login. And I found evidence of people laser sintering with these ODS materials as far back as 2015, but the results were pretty poor. This material, in all of the major news outlets, the lead line is it lasts 1,000 times longer, which I know you're going to love.
That's what I was going to bring up.
NASA develops material that lasts 1,000 times longer.
It says NASA's new 3D printing alloy. This is a headline on a local news feed. NASA's new 3D printing alloy 1,000 times more durable than existing aerospace alloys.
So that's
why I was laughing earlier, because as soon as I saw that, I was like, perfect.
The one time we named an episode that, our numbers skyrocketed, right? So, and actually NASA didn't release much information at all. They just gave some kind of semi-numerical numbers. They said it lasts 1,000 times longer, which you would have to know a little bit about material science to know maybe or suspect what that means. Meaning, if it lasts longer, that's generally associated with fatigue. But then once you bring in the high temperature, then you're also talking about creep. So the creep and the fatigue at elevated temperatures is going to be 1,000 times longer than something. And I just think that the use of these oxides enabled by printing and creating materials that are engineered specific for applications it's exciting. It's really exciting.
It is. You're going to hate me for this.
What?
You know all I could think about while you were telling me this?
What?
3D printed meat.
Oh my God. What about it?
Like a ribeye.
Yeah.
Because they're placing the fats and everything like just perfectly, or trying.
Wow.
It's really changing the way we eat.
The guys at the NASA, I wrote down the department that developed this because it's badass. Transformational Tools and Technologies. Imagine saying, I work at NASA in the Transformational Tools and Technologies department. How awesome.
No.
They're going to be like, oh, everything we did, and you compared us to printed meat. Thanks, Tate.
You're welcome. This is what part of what makes me the everyman.
Yep.
So,
but can you grill it?
Taste the meat, not the heat. So, that pretty much does it up. I mean, I will maybe I should just primer us for next week.
Yeah.
No?
Do it.
Why are you laughing? Let's talk about this. What did I do?
Because you're coming back and you're like, man, we keep making these promises that
this is a promise I can keep. I've got a page worth of notes for next episode.
What if something really important happens
You
in the next
have
week?
these notes.
If
and
something,
it's your job.
something
It could happen to both of us.
world-altering happens in the next week, and then we sit down here at the pod and we're like, man, we really want to talk about this, but Tate committed the conversation to this.
So you're asking me to either turn it into like a 30-second blip now,
No.
or turn it into a 30-second blip then if something happens like that. So
I'm going to let you...
long story short, I'm going to have to compress this.
Okay.
Is that what you're saying?
Do you have the time to do it?
Is that what you're saying?
Do you have the time to do it?
Look, your superpower is being able to condense things in just the right way. Like I could sit down for 10 minutes and try and write out a sentence. You can do it on the fly.
Okay.
That's your superpower, not mine. Definitely not mine. I'm a wordy son of a gun.
Mm-hmm.
I don't have the vocabulary.
You use a lot of words.
It's embarrassing. I'm really vulnerable on this show. Okay. But yeah, especially sitting next to you.
I'm going to leave it up to you. We can talk about it, or we can close the pod out with something else.
Material Minute.
Okay. Material Minute.
This is a new segment.
Okay. That you're inventing right now.
Right now.
Okay.
Because I don't have a YouTube of the day.
Okay.
And maybe we won't do that every episode.
Our YouTube of the day now every week is our own YouTube. Because we're on YouTube.
No.
Bad idea?
No. Terrible. But if you want to watch the pod, you want to meet me and Tyler, see what we look like, watch it on YouTube.
Yep.
No. For the Material Minute today, and I'm going to set a timer. You and I are both going to do this. It's not going to be
what?
It's not going to be just me.
Okay.
We're going to do
This seems unfair.
ABS CF10. It's not unfair. I have the computer that helps me.
I already gave
You've
a
got
minute.
the old bear trap.
I already gave a
helps
minute
you.
on this.
You didn't really talk about the materials.
Okay, let's go.
I think the people deserve a more in-depth look at what ABS CF10 really is, or just make some quick comparisons. Why do we use it? Know what I'm saying?
Okay.
You ready for this?
Sure.
Can we keep it under a minute?
A minute combined?
Ready?
Or a minute each?
No, minute combined.
Okay.
I'm starting it now.
I'm going to give you 50 seconds.
Material Minute. ABS CF10. I actually don't have the PDF pulled up. So ABS CF10 is basically a 10% carbon fiber filled. Now these are, I think they call them like nanofilaments, or they're strands of carbon fiber.
Everything's nano if you are willing to count in bigger numbers.
It's true.
Yeah.
We're not going to go there.
Okay.
This material is, the claim to fame is it's stronger, it's stiffer than traditional ABS, and obviously lighter. Now, here's what Stratasys has to say about it. It's over 50% stiffer and 15% stronger than standard ABS. So there's some numbers for you. And what this material was really designed for was to be able to, we got 10 seconds, replace aluminum or metal in some end-use scenarios, jigs and fixtures, things like that.
Okay.
Whew, we didn't really get there. Material Minute's going to be tough. Oh my, how embarrassing.
You need more than a minute.
What? Did we?
You needed a lot longer than a minute.
This is a practice run, all right? Everybody give me, don't laugh.
I like how you just love the name of it.
It's
the 1 minute material segment where I talk about a material for 5 minutes.
This is, wow. This is the first time you're really doing this to me on air.
Just razzing you?
This hurts. Yeah, I'm flustered. I'm beat red. Yeah, I couldn't do it in a minute. You're proud of yourself right now, aren't you? Mm-hmm. Yeah, he's soaking this up. Okay, so I couldn't do it in a minute. I'm going to practice next time, alone at my desk.
You need to script it out.
Thanks. This Material Minute was brought to you by Juicy Filaments.
Juicy Filaments.
Okay, so that's pretty much it for the episode. I think we're going to try and stick to a couple of these segments. I'll do a better job at staying under a minute, or I'll make you do it. But that was pretty good. We recapped. We talked about things that we followed up on things that we promised we would.
Yep. That was
we
important.
had our first phone interview with a colleague.
Yep. That was
Also good.
Also good.
You got to talk about rocketry.
A little bit.
And I got to make
you
fun of
let me finish, which was awesome.
I got to make fun of you too a little bit. So this was
we
fun.
learned what a scramjet is.
Yes, we did.
Kind of, sort of.
And I don't know. I thought this was a good episode. At least maybe some people get some laughs out of it and learn something.
This is our 45th good episode. So thank you for watching. Thank you for listening.
We'll talk to you next week.
On the 46th episode. 46th episode.
46. Look forward to seeing you.
See ya.